I've had a few questions about my ventilation system and also about my in-floor heating system. And so I figured that I would make a video and talk about them a little bit. So first off, I'm going to talk about my ventilation system. It's a little bit unique in the way that it actually doesn't use any ductwork except for a short piece that goes down through a shelf, which I will show you over there. But it uses a furnace fan to move the air, a light switch as the switching device, and it puts the exhaust air, it exhausts it out through the soffit of the building. I've got 3 vents. One is here. One of them is close to the center of the garage, right here. And then I've got another one over here, which is by the milling machine and the lathe, just above this shelf. Now, that one is the only one that uses a duct. If you look behind that blue box, or black box rather, you may be able to see a duct coming down there, and that's just so that it can penetrate through the shelf and pull the air through here. So the reason why I have that vent there is because when I'm working at the lathe or the milling machine, but especially the lathe, smoke comes up, fumes come up from the work that you're doing, and when I have it there, it pulls the smoke kind of away from me, which is good. When I have it up there, the smoke would have to go up in this direction and it would kind of pull it right through where I'm breathing. So I decided to put the vent here. Originally this was a welding station, and then I decided that I didn't have enough room in my shop for a dedicated welding station, so it became the area for my lathe and milling machine. So those are the vents that pull the air out of the shop. There's 3 of them in total, and you may have noticed that 2 of them have flaps on them. So if you've got a car running in here or a lawn tractor or something, it makes sense to try to move just a large volume of air. Or if I'm sweeping and there's a lot of dust, it can move a large volume of air and pull that air out of the shop. But when I'm working here at the mill or the lathe, it's good to have a lot of velocity and a lot of air volume flowing out through here. So what I do is I close those vents. And it's very low tech, but it works very well, and it's quite easy to do. So I'll show you how I do that right now. So the switch for the ventilation is right here by the programmable thermostat for the floor heating. I just turn that switch on, and you will hear the ventilation system is now running. So what I do is I take a long pokey stick, usually my broom, and I come over here, I push that flap up and the vacuum holds it shut. I push that flap shut and the same thing, the vacuum just holds them shut. Like I mentioned earlier, there's no ductwork in the system except for that one small piece over there. And you probably noticed that the vents are all in a row. They follow a straight line across the shop. So we've got one in behind that tire, we've got one right here, and then we've got one directly back there. And the reason for that is because the ductwork is actually the joist cavity. So what I've done basically is sandwiched the joist cavities. So if you can picture, there is one joist that runs here, another joist runs here, and I have a piece of OSB on the bottom, and then on the top side I have the floor of the attic. So it creates a cavity that the air can flow through. Air flows out of the shop into the vents, which are represented by the blue arrows, and then they flow through the floor cavity or the joist cavity and travel to the furnace fan. If you look at the green arrows, the air passes through the fan and then is blown out through a joist cavity that is sandwiched between the roof and the attic travels out in the direction of the green arrows and then down through the soffit. So I will take you guys outside now and show you where the air actually exits the building. All right, so that is the exit of the ventilation system through the soffit. And that is the vent. So I've opened up the hatch to my attic and we're going to take a look up there. You won't be able to see a whole lot, but you'll be able to see something. So if you see here, we've got the joist cavities in the attic, and behind that piece of MDF is where the furnace fan is. You can see there's oriented strand board here and on the other side, and then this is basically an access hatch to the furnace fan. So on the other side of that, the furnace fan is sitting on the floor, and it pulls air up out of the floor and then puts it into the joist cavity along the roof and pushes it out through that soffit. So that's basically it for the ventilation system. If I wasn't clear about something, if you've got questions, you can always leave a question in the comment section and I'll be sure to answer you. If it's something that's a little bit detailed, what I might do is actually answer you in video form in the random shop talk videos. Yeah, that's basically the system. It's fairly simple, and it's a nice and clean setup. There's nothing poking into the shop, and yeah, works quite well. So as far as in-floor heating systems go, or radiant heating, hydronic heating, whatever you want to call it, mine is fairly basic. I've got 4 separate pieces of PEX tubing going through the floor, and they can be controlled independently, but I always just leave them wide open. The idea was that I could control whether or not I wanted the area by the door heated. If we end up with a situation where the garage door is freezing shut due to freezing rain or snow or whatever, I can run heat to underneath the door basically, and it melts along that edge. So I just leave them all turned on so the whole floor gets heated, and it works quite well. I've never really bothered playing with any of the valves, but it is there if I do want to use that. There's a couple things that are a little unique to my system. I built my own air separator, which works really well. I'm quite proud of it actually. And it's all enclosed in one tidy little place. All of the system, except for the PEX tubing in the floor, is all enclosed over in this corner, which I will show you in a minute. And yeah, it's worked flawlessly. I'm not saying that this is the way that you should do it. I'm not saying this is the way that any professional would recommend that you do it. I am not a professional or an installer by any means, but this is how I did it. I've had it for about 3 years and I haven't had a single issue. So anyway, now let's get to it and I will show you guys my in-floor heating system. This is the area that it's housed, and as you can see, it looks fairly tidy and inconspicuous. The only thing you can see here is the expansion tank. Here we have the fill filter. This is a fill valve, so this would be a fill tube, I guess. We have the expansion tank, which keeps the system pressurized and allows for expansion of the water. I have a pressure relief valve so that if it does overpressurize, it can blow some water off. Right here, we have the top of my homemade air separator, and we'll get into that a little bit later. Right, if we move to the bottom, you can see there's a door here, and in behind the door is where all the goodies are. So right here we've got the controller for the tankless water heater, which basically just sets your temperature of the water. So this is preset at 104 Fahrenheit. And so when the heater turns on, it tries to maintain the water at 104 Fahrenheit. We've got a gauge. This is the temperature and pressure that the water is entering the floor. And over there is the temperature and pressure that the water is exiting the floor. That black guy there is the water pump. The green box is a relay control box. And the heater itself is right there. As you can see, we've got some plumbing and a few more valves. And that's basically the system. So now I'll go through and explain to you guys basically the flow of water, so how it travels through the system. Now, the current temperature in my garage is 15 degrees Celsius. So this is a normal thermostat for a gas heater or oil heater. This is bought from Home Depot, nothing special. It's just your standard programmable thermostat. What it does is it sends power down to this relay box, and you can see there's a wire going into the top of it. That is the wire that comes from the thermostat. There is two wires that come out of the bottom of that box. One of them comes from the wall outlet. So the one on the left comes from a wall outlet, and the one on the right goes into the pump. So when the thermostat calls for heat, instead of turning a furnace on or turning a heater on, it turns that pump on. When the pump pumps the water, it goes into the bottom of the tankless water heater. And in this case, the tankless water heater has a flow sensor in it, which detects the flow of water. So as soon as the pump turns on, the water starts flowing, the heater turns on. So the water that comes out here is 105 Fahrenheit. That water goes through this tube, through some 3/4 inch PEX tubing. It goes all the way up here, which you guys can't see because this panel is screwed on. It comes all the way across and it goes into the top of my air separator. And then it goes all the way down here through the water separator, and you will probably be able to see it here if I get some light on it. So that is the bottom of the air separator. It is 3-inch ABS pipe. Alright, so it comes out of the bottom of the air separator, and it comes down through this 3/4 PEX tubing, across into a manifold. These are the valves that I talked about. And you can see they're numbered 1, 2, 3, 4, and they're labeled 1, 2, 3, 4 here as well. So they go into the floor here, they go all through the floor, and then they come back out and into this manifold, which then goes up through a ball valve, through this gauge, and back to the pump. Because this system is custom built, I didn't have the same kind of space restrictions or kind of design restraints that the average person may have. So the way that I built this, or the way that I designed this, was instead of coming out of the water heater and going down into the floor, you see it would have been very easy for me to come out of the bottom of the water heater and just go straight down into that manifold. The problem with that is that if you're going to get air, it is most likely going to be after the water is heated. So the hotter water is going to tend to form bubbles in it. So the water comes out of the bottom of the water heater, and say we've got a giant bubble in here for some reason. Well, the flow in this 3/4 inch tubing, when the pump is running, the water that's flowing through here is moving at a pretty good pace. Well, the flow of the water is moving fast enough through the 3/4 inch tubing that it is very easily going to push it over to this area. And we have 3 feet of vertical 3/4 tubing there, and we all know that air wants to raise in water. So the bubble naturally wants to go to the top. plus we have fast water coming through behind it, pushing it. So any air that gets trapped in there is automatically going to shoot up through this 3/4 tubing and across here. Now, the two things that happen when it gets here are why this system works so well. For one, it goes from 3/4 inch tubing into a 3-inch ABS pipe. So in behind here, there's a 3-inch ABS pipe that goes 3 feet down. So if you know anything about flow rates, when you have a 3/4 inch pipe that's going into a 3-inch pipe, if you have the same volume of water traveling through, the velocity of the water or the speed of the water is greatly going to decrease. So we have the air bubble that got trapped in here, and it's moving quite fast through the 3/4 inch tubing, but as soon as it gets into here, all of a sudden it slows down. It goes into a very large area and it slows down. Now, in order for that air bubble to get back into the system, it would have to defy the laws of physics and fight its way down through 3 feet of water before it could get down to here and make its way out. So the two reasons why the air separator works so well is because, one, it's 3 feet long and you'd be trying to push a bubble 3 feet down. And the other thing is because the speed of the water in this tube is very, very slow. Because this column of water is so large, it moves very slowly. And so those two things mean that any air that enters at the top of this is going to stay at the top of this. So the 3/4 inch line comes in just below this shelf, and it comes into a T into the side of this 3-inch ABS pipe. So any air bubbles that get in here float up through this tube and make their way up, and they basically fill this column. So if I have any air in the system, all I need to do is come in here and either push this valve, and you can see that's pure water that squirted out of there. I'm not sure if you could see actually, but I could. If you look closely at the top of this filter, you can see there's water sitting in there. And if I open the valve, you'll see that water level rises. If there's any air in the system, it will come out through the top of the fill filter. And we can see the level of water rose. No air come out, no bubbles come out, so there's no air in the system. Alright, I'm sorry for yammering on so much about my air separator, but I'm quite proud of it. It's worked flawlessly for over 3 years. I'm sure there's lots of people out there who will give me all kinds of reasons as why I shouldn't have used 3-inch pipe, I shouldn't have used ABS, I should be using different valves. I'm sure there's all kinds of people out there who are going to tell me that I should be doing this different, but it's worked flawlessly for me for 3 years, and it's extremely quiet. I know several other people who have hydronic systems, who have in-floor heating, and the pumps are constantly making noises, and you can hear the air bubbles running through stuff. And I have never once had any of that problem. I filled it and ran it for probably less than 5 minutes before all of the air was gone out of the system. Anyway, so now what I'll do is I'll turn the thermostat up. You guys can hear it turn on and hear it operating. So what I'll do is I'll set the camera down in this area. And because it's very enclosed, it will actually seem a little bit noisy, I'm sure, but yeah, not noisy compared to the Mr. Heater. We're at 15 degrees. We'll go to 18. Oh. We hear, oh, it clicked. The light came on that guy. You can hear the water heater just turned on. The green light is on my controller. And now we will see slowly the temperature on this gauge will start to increase. Also, there's an indicator on the controller here. You can see it's flashing, and that is telling me that water is running. So it's telling me that there's flow. We can see we're almost up to 30 degrees in the water temperature already. And the reason why this doesn't go up instantly is because the water is coming out of the bottom of the heater. And remember, after it comes out of the bottom of the heater, it comes up through the wall and down into this air separator. And that air separator probably holds about 5 liters, probably holds about 4 liters. I don't know, I could do the math, I guess. It's 3-inch tubing, 3 feet long, so you can do the math, the whole, yeah, pi r square times height or whatever. And we could figure out the volume of the water in there. But anyway, the reason why it takes a while to actually show the temperature difference on this gauge is because it's on the bottom of the air separator, and it actually is heating up all of the water through that air separator before it gets to the gauge and then goes down into the floor. And if we take a look over here, we can see the temperature coming out of the floor is still only about 15 degrees, which is good because the idea is that we lose heat in the floor. So we want the heat to be going into the floor and then into the air. So what happens is we've got the water going into the floor here. It's about 30 degrees now. And the water that's coming out of the floor is about 15 or 16 degrees. And so it means that that heat is coming up through the floor and into the air and heating my building. And now we'll turn this back down because I'm going in the house to edit some videos. 12 degrees, and we'll hear this turn off in a second here. There we go. It goes through a little shutdown cycle. It speeds up, slows right down, and eventually it turns right off. So if you guys have any questions about my in-floor heating or my ventilation system, I'd be happy to answer. Just leave a question in the comments. If you want to call me a big dumb goof and tell me all the things that I did wrong, feel free to leave that in the comments as well. Yeah. If you think that I'm ridiculous for doing it the way that I did it, or if you think that it's going to cause some kind of catastrophic explosion that leads to the end of the world, be sure to leave that in the comments so that I can do something about it. And yeah, that's the end of the video for today, so I will see you guys next time.